Hi everyone, in this lecture we are going to talk about universal functions. Universal functions are going to allow us to use trigonometric operations and mathematical operations in NumPy. So what I've done is I've imported NumPy as NP, and then I have also created an angles array with 0, 30, 45, 60, and 90 as elements. So first things first, let's go ahead and let's take a look at how we can convert angles or degrees into radians. So I'm going to say angle radians. And for that, we are going to grab our angles and we are going to multiply it by np.pi divided by 180. And now let's take a look at it. Angle radians. These are angel. Okay, this is misspelled. Just run this again. Angle radians is not defined. Radians, there's another typo. There we go. So these are the radians equivalent for these angles. Now, how can we find the sine of the angles? To be able to find the sine, we can basically say print np.sine. I'm going to provide a comment and I'm going to say sine. All right, so the function is np.sine, and you need to pass in some angles. And I'm going to pass in angles radians. And if I run it, angle radians. Why do I keep making typos? There we go. So we got 0, 0.5, 0.0, 0.8, and 1, as we would have expected, right? We can also use the radians method to convert all the angles to radians. There is also a radians method instead of like this formula that you have to memorize. So I could say angles radians. Now this is angles radians. And I'm going to set it to np.radian. Radian. Let's pass in our angles that we have. Let's run that. np.radians. I mean, like in this lecture, I have to make mistake at every line, apparently. So angles radians. This is the problem of working with editors like VS Code, that they allow you, like they complete your variable names and all of that, and you have like, it is a bad practice for you, because when it comes to Jupyter and you don't have that functionality, or you don't want to work with it, you're going to end up with making a lot of mistakes. So now let's find the cosine of the angles. So I'm basically going to say print. Instead of sine, I'm going to say cosine. And this is going to be cos. Right? There we go. So, and I'm going to pass in angles radians. There we go. So this is the cosine. We can also find the tangent of the angles, and tangent, which is sine over cosine. So 10 is going to be the method name, and let's run it. This is the tangent. You can also find the sine inverse or arc sine of the angles. For that, I'm going to create sine, and I'm going to say np.sine. Let's grab our angles, multiply them by np.pi divided by 180, and then I'm going to say inverse. Let's grab np.sine, np.arc sine, and let's pass in the sine. And now we are going to say print inv, which is short for inverse. So this is the arc sine of those angles. We can also convert the radians to degrees as well. So we can say print np.degrees is the method, which is going to convert radians into degrees. And if you just say inverse, it is basically going to convert them to degrees as, again, 0, 30, 45, 60, and 90. So we are done with basic trigonometric functions. These are very important when it comes to NumPy, because NumPy is highly computational driven. There is a lot of computations in NumPy. That's why you need to be familiar with these functions, that they actually exist. Now, what I would like to do is I would like to create a test scores array, which we have these numbers. I mean, it's going to take so long if I create it manually. Now, let's find the mean or the average. So I'm going to say print mean test scores. And we have a method called mean. Mean is going to give us the average. So I'm going to pass in test scores. And if I run it, this is the average of this test. So mean test score, not scores. We can also find the median. These are statistical functions. So we have mean, median, variance, we have normal distribution, and all of that good. Standard distribution, which we're going to take a look at, and variance in this lecture. How can we find the median? Let me just grab this print statement, put it right here. And I'm going to say median, and it is in p dot median. And basically we are going to pass in test scores. In case you're not familiar with the median is the middle number in a sorted ascending or descending list of numbers. And it can be more descriptive of the data set that we have than just using the average. This is more descriptive. The median is 43.405. Now that we are done with mean and the median, I would like to show you the standard distribution as well and variance. For that, we are going to load data from external files using NumPy. And I'm going to say salaries. Now, if you come in here, to exploring multidimensional data, in here we have a salaries CSV file, which I'm going to import into NumPy. So how can NumPy import CSV files? We had the read CSV API for pandas. We have the gen from TXT API for NumPy. NumPy can do that as well. Gen from TXT. Let's pass in the path. So it is within the data folder. The name is salary.csv. And we need to provide a delimiter as well, which is going to be, this basically shows how the data is separated from one another. It's going to be a comma. Now let's take a look at salaries. Salaries is going to be a one-dimensional array of salaries. We can take a look at the length of the salaries or the shape of the salaries. So I'm going to say salaries.shape. Let me just remove that. So it is a one-dimensional. You can see it returns a tuple, and when you want to have only one item within your tuple, you need to provide a trailing comma. So there are 1147 salaries in this array. Now let's start exploring the salaries array. So what I would like to do is I would like to find the mean for our salaries in p.mean, and I'm going to pass in salaries. Let's grab the median as well in p.median. You can see how easy and seamless it is. Whenever you have data in CSV, you load it into NumPy, and it's very fast, very efficient. Let's grab the STD or standard deviation. And now the standard deviation is going to be computed along a specific or specified axis. In statistics, the standard deviation is the measure of the amount of variation or dispersion of a set of values. Now, a low standard deviation indicates that the values tend to be close to the mean, which are also called the expected value of the set. And a high standard deviation indicates that the values are spread out over a wide range, right? So we also have variance. We are going to talk about that next. So we're going to have STD, let's pass in salaries. And I'm going to do variance np.var salaries. Now, computing the variance is going to be done along a specific or specified axis. In probability theory and statistics, variance is the expectation of squared deviation of a random value or variable from its mean. Now, how much a specific point deviates from the mean, which is the average, that is going to specify the variance. That is the variance. In other words, it measures how far a set of numbers is spread out from their average value. Now, standard deviation, it is going to indicate the values are spread out over a wide range, but variance is how far they are from their mean values. Now let's create print statements, which I'm gonna do. I'm gonna say mean, and I'm gonna grab mean for that. Let's copy that. This is median. Let's pass in median. This could have been very easy with VS Code. std, std, and this is variance. Let's run that. We have an error. Variance. Okay, variance. It's not defined. There we go. So the mean is the average salary is 55,894. The median is 48,000. Standard deviation is 55,170, and the variance is this much. So this is the variance that we have. With this, our lecture comes to an end. See you in the next one.